Oh yes, hello viewers. My name is Nathan Matovu here at Kisa Projects. Kisa Projects is a home for entrepreneurs and we are located at Komamboga-kumukaaga along Gayaza Rd. Today I'm here to take you through the process of soap production. Basically how to make quality laundry bars of soap, like those bars of soap you see on the market manufactured by the big brands. You can do it from your home using simple equipment. It's what I'm going to show you here today. Right from scratch, right from mixing ingredients, to molding the soap, to stamping the soap, to putting the soap into a wrapping cavera. Then after wrapping it in the cavera, finally we shall seal it with using our band sealing machine, and we shall put it on the market for sale, or we shall put it under use by our own selves, or we shall give it to any of our customer as a sample to use. If you need training from us, you can just come over to our center. We're here at Komamboga-kumukaaga along Gayaza Rd, and our training fee is 100,000. Continue watching, see how we do it here. So here are some of the tools we're going to use for our soap production today. As we are seeing, Madam Mille is holding a luxury hand mixer or hand blender. It is made of stainless steel. So we shall need one to help us in mixing of our soap. We shall need a hand mixer. That is tool number 1. Number 2, we shall also need a certified digital scale, the one that can measure in 1 gram increments, like that one. Number 3, I'm also going to use a silicone mold, a rubber silicone mold, like that one, for molding my soap. So those are my basic tools, the one I'm going to use for my soap production today. Let me show you how I'm going to use these few tools to make quality bar of soap. Keep watching. Yes, so here we get started. I get my digital scale and I start measuring the weight of my ingredients that I'm going to use for soap production.
To enable clients set up their tiny, small or large industrial ventures, we supply chemicals and machinery. We are located at Komamboga-kumukaaga along Gayaza Rd. Call +256 7.
So these are my fatty acids.
194, and follow us on Facebook at Gayaza Projects Africa.
These are fatty acids for making brown soap or colored soap, brown, red, yellow, blue, any colored soap of your choice you can use such fatty acids. It's not chocolate, they are fatty acids. Here now, as you can see, our fatty acids are on heat source. Now we are boiling them up so that they get melted, or we are melting them up. So now we can observe that our oils are melting up. So Madam Mille is going to come to help me in stirring, speed up the rate of melting. Yeah. Now we are stirring so that we can faster the melting process. Yes, so now we can observe that our oils are fully melted and good for use for soap production. So after melting our fatty acids, the next step is to prepare our additives. Like number 1 here, I have my superfatting oil. Now these oils shall be used to make my soap more of an oil substance than an alkaline, so that when I use my soap on the skin, it leaves my skin oily and not dry. So these are our superfatting oils, the one I'm going to use in my soap production formula today. Number 2, I'll also need a fragrance oil. So this is a fragrance oil. It adds a good scent into my bar of soap so that my soap can attract customers. Number 3, I will need a filler. This is a filler. It compacts soap molecules tightly together and it gives soap weight. So for me to make a bar of soap that weighs 1 kilogram and it is in the size of the 1 kilogram bar of soap that we are used to seeing in the market, I'll use a filler so that it compacts soap molecules tightly together to give my bar of soap weight. I'll also use a leavening substance. So this is a leavening substance. It also contributes to the amount of foam produced by my soap, and it helps my ingredients to combine together. Remember, scientific oils and water can't dissolve in one another. So I'll use a leavening substance to force that reaction between my oily substance and the water substance that I'm using in my formula. This one shall also help me to cut costs of production of my soap. This is the leavening substance. Lastly, I will need a strong alkaline solution. This is a strong alkaline solution. Remember the process for making soap, we said it's saponification. And saponification, we need fatty acids and a strong alkaline solution. So this is a strong alkaline solution. It's a combination of caustic soda or sodium hydroxide with water. So we shall also need this one in our soap production formula. The next step is to combine them into making a good quality bar of soap. Keep watching. Let's get into the production area. So here we get into the actual thing. I'll start by, but I'll not speak because this is our credential formula. If you want to get a copy of it, you just come here at our center and we train you. Just watch and see how my beautiful bar of soap is going to come out. So if your intention is to make colored soap, you can add color. But for me, my intention is to make a brown bar of soap. So I'll not add any color to it. The fatty acids I'm using are for making colored soap. You can't use them for making white soap, but you can use them to make any other color, like blue, green, red. If you want to make white soap still, you can keep scrolling on our YouTube channel. You'll see videos on how to make a white beautiful bar of soap. So you can see that our soap is now ready. It looks beautiful. My friend, if you're making soap on a cottage scale, it will be hard for you to get to this stage unless you get training from KISA projects. Yeah. Don't try this before you get training from us. Otherwise, you'll end up making mistakes and your soap won't come out. It's better you come here for training. This is the sample I have made. It will always be here available for some of our clients who will come here. We shall give it to you as a free sample for you to test how it works. Yeah, so you can see that our soap is ready. This is the soap, not colored, using my coffee fatty acids. If you want to get this formula, we can train you how to make soaps of different colors: blue, white, like this coffee brown, green, yellow, any other color of your choice, black, African soap. All those formulas are already available here at KISA Projects, and when you pay just 100,000 for training, you get all those formulas for laundry bar soap production. So after my soap getting to this stage, I'll add my super fattening oil to make my soap more of an oil substance than an alkaline. So this is my super fattening oil. I add it. And I mix it into the soap to make my soap very nice on the human skin. This is a good bar of soap. Yeah, I've used just 1,700 shillings to manufacture all this batch. All this batch is 1,000 grams. But if I'm selling it on the market, I can even sell it at 6,000 because it's a very beautiful bar of soap. Very effective on the human skin. Very gentle. This is what we do at KISA projects. We don't just speak, we act. So you see that my soap is nearly forming, because it's already a soap at this point. So the moment I remove it from the mixer, it will be just solidifying. I have to add a fragrance oil to it. I'll add sufficient quantity. And after adding it, I mix it into the soap rapidly. Don't have to over mix it because it will end up spread exploding out of the soap. Measure consistently by weight, not by volume. Never measure ingredients by volume, such as by cups or spoons. Always measure ingredients by weight, such as by grams or ounces or pounds. Be sure to use the same unit of measure for all the ingredients. Consistently measure both the lye and the fats in grams, or measure both the lye and fats in ounces. For example, the first fat listed is almond oil, which has a listed lye saponification value of 0.1367. So, it will require 0.1367 of an ounce of lye to saponify 1 ounce of almond oil. Also, 0.1367 of a gram of lye is needed to saponify 1 gram of almond oil. Likewise, 0.1367 of a pound of lye will saponify 1 pound of almond oil. Yes, so that is how our process has gone, and we are done with our soap. Now we are leaving it to get cured and to complete the saponification process. Saponification chart. The chart we share at KISA projects lists an average of the known saponification value of specific oils. It was compiled in 2006 by contacting dozens of oil distributors and processors to obtain their most recent and most exact saponification values. Then the different saponification values for each fat were uniformly converted to sodium hydroxide values and were averaged. The precise saponification value for a specific fat must be required from the distributor because the exact molecular weight of each fat will vary by crop and processing method. For example, 2 different palm oils will have slightly different saponification values because the 2 oils may have been processed from different crops harvested at different times of the year and processed by different extraction methods. The values given at KISA projects are the most accurate average saponification values on Earth and may be trusted to accurately saponify the listed fat. To learn the exact and average saponification value for a specific fat, contact the distributor. Hence, we therefore suggest to you that it is always best to purchase your oils from us.
To enable clients set up their tiny, small or large industrial ventures, we supply chemicals and machinery. We are located at
Yeah, so we can see now our beautiful bar of soap is here. So as we said, I'm going to divide it into 5 partitions. Let me first remove this area to show you how it looks inside. So you see how our soap looks. Yeah, so this is how the inside of our soap looks. It's a good bar of soap, as you can see it. So if you are making soap and you're out there, so this is how best you will test your soap. A good bar of soap should be very strong. As in when you try to compress it, you feel like you find that the bar of soap is very strong. However, it should be mild, not too hard like a piece of wood. Mild. In the course of breaking, it should not make any sound. Like the way you see when I just break, not cutting. See the inside of my soap? So this is how the inside of your soap should look like if you just break it, not cutting. I have not used the pruder. So if I use a pruder, I'll get the very fine ending of my soap. However, there are many people who use a pruder in making soap and they can't even get to this quality. So those are the advantages of getting trained at KISA projects. We have just used simple equipment. You have been seeing it practically as we are doing it right from scratch. Yeah, so this is how nice our beautiful bar of soap looks. Calculations and measuring water. Calculating and measuring water. Water is needed to dissolve lye, sodium hydroxide, and for the hydrolysis of the fats. Using too much water may produce soft bars of soap, may demand extra drying time, or may encourage rancidity. Because the water is used to dissolve the lye, the most of lye will determine the amount of water. To calculate the correct amount of water, first determine the total amount of lye, sodium hydroxide, divide the amount of lye by 0.3, and then subtract the amount of lye from the result. For instance, amount of fat times saponification value of the fat will be equal to amount of lye, and amount of lye divided by 0.3 will be equal to total weight of lye water solution. Total weight of lye water solution minus amount of lye will be equal to amount of water. Remember, after weighing the lye, sodium hydroxide and water, always add the lye to the water, never add water to the lye.
Welcome to TISA Projects, a home for entrepreneurs. At TISA Projects, no one can be too young to own a company. We empower practical entrepreneurial skills to enable clients set up their tiny, small or large industrial ventures. We supply chemicals and machinery. We are located
Saponification.
at Komamboga-kumukaaga.
Saponification is the chemical process of making soap that involves an exothermic reaction between lye, sodium hydroxide, and a fat, usually oils. What is commonly known as cold process soap making yields a glycerin-rich soap, which used to be referred to as lye soap. People often think of lye soap as a soap that is unpleasant to be used because too much lye was used in soap formula, and lye, sodium hydroxide, remain in the bar of soap to irritate and burn the skin. Soap cannot be made without lye. When made correctly, no lye will remain in the bar of soap. Throughout history, soap was made by rendering available animal fats and adding natural lye leached from ashes to make soap. Without the scientific data readily available today, the soap makers of yesteryear approximated the amount of lye to add to the fats. If not enough lye was added, with too many fats remaining, the mixture would separate, not be usable, and the effort and time of preparation would be wasted. If too much lye was added, some extra would remain in the soap, but the soap could be used. Therefore, the preference was to add extra lye to ensure the soap would be usable. However, the extra lye remaining in the bar of soap made it unpleasant to be used because it would often irritate or burn the skin. However, today, with easy access to the exact composition of fats and the molecular weight of a fat, especially here at KISA Projects, it is easy to determine the exact amount of lye needed to completely saponify a measured amount of specific fat. So, there will not be any extra lye in the soap, and the soap will not irritate the skin. The number of milligrams of lye, that is sodium hydroxide, if at all we are making bar soaps, and that is potassium hydroxide, if at all we are making soft soaps or liquid soaps. Hence, the number of milligrams of sodium hydroxide, like for our case, required to completely saponify 1 gram of a specific fat is referred to as the saponification value. However, laboratories usually refer to the saponification value of potassium hydroxide, not sodium hydroxide. Potassium hydroxide is commonly used to make liquid soap, and sodium hydroxide is necessary for making solid bars of soap, like the ones we were seeing here. The numbers in the chart of saponification value shared at KISA Projects are both for lye, sodium hydroxide, and for potassium hydroxide, and have been converted from milligrams to be generically applicable to any consistent unit of weight. So if you want to learn how to make white bars of soap, you can just come over here at KISA Projects for training.